Section 12.3 has continued our discussion of constructions, and we worked last time on two constructions, actually three, we did three. Two constructions were the same thing. They were creating parallel lines. One was the rhombus method for creating parallel lines, and the other one was the corresponding angle method for creating parallel lines. And then we talked about bisecting, or cutting angles in half, and we created an angle bisector as our third construction for last time. If you weren't here, or if you need to remind yourself how those are done later, of course you can see the videos that are posted online, videos 8, 9, and 10. So we're going to continue in our discussion of angle bisectors with a little bit more about them. So some more about angle bisectors. Any point is on an angle bisector if and only if the point is equidistant from the sides of the angle. You have to be careful when you talk about distances. When we talk about distances in geometry, we mean the shortest distance. And the shortest distance is when we go to a perpendicular. So you'll see the note there where it says the distance from a point to a line is the length of the perpendicular segment from the point to the line. And these are identical pictures, but you can kind of see how they're sort of created. There's sort of this inherent circle that could be drawn in there, and we have these perpendiculars that may meet the sides of the circle at our angle. Okay? So we're always talking about perpendicular distances. The incenter is a single point of intersection of the three angle bisectors of the triangle. We also know that the three distances from the incenter to the sides are equal. So jot those down, and I'd like for you to try to think about why it is that I can say that we know that. Why do we know that the incenter, the center of this triangle that's inside, is equidistant from the three sides of my triangle? Any thoughts? What are those blue lines that are drawn in this picture? I only have two of them drawn in, but what are they? You got it. Those are angle bisectors, okay? And part of the reason I know they're angle bisectors is because this previous slide said we're going to bisect these angles, and this point's going to be equal distances away. And over here, it says that the incenter is the point of intersection of the angle bisectors. And I know it's been like 3 days since we did it, but if you'll remember, the way that we created angle bisectors is we did these two arcs that intersected. And do you see out here that that's exactly what happens? Just this construction markings out there. That's actually what's going on there and here to create those. So these are angle bisectors. Oops, sorry. That's what I want to do. So my angle bisectors cut angles in half, and they form the incenter. And by definition over here, a point that is on the angle bisector, and that's what this is. This point P is on two angle bisectors. It's actually on three. The other one's just not drawn in. But it's on an angle bisector, has to actually be equidistant from the sides. So if we talk about, I did it again, if we talk about that point P, and we look at, let's look at this angle down here at the bottom over here, angle B. It's going to be equal distances here and here because it's on the angle bisector of angle B. And likewise, it has to be equal distances, oh my goodness, has to be equal distances here and here because it's on the angle bisector of A as well. And we could talk about angle C the same way. There's nothing special about the two that are chosen, but we do have those two pieces there. All right, let's talk about something else that happened here. I kind of avoided using the word because we hadn't defined it yet. Tangent line. I know you've heard about tangent lines before. The first time you probably heard about them was probably in geometry, maybe high school, maybe earlier. You might also have used a word tangent to mean other things. When you talk about like sine, cosine, tangent in trig or pre-calculus, something like that. A tangent line is a line that intersects a circle at exactly one point. We often think about tangent lines as sort of bouncing off of circles, right? They don't actually cut through. They touch them only, or they bounce off. A line perpendicular to the radius at a circle's edge is tangent to the circle. So, the sides of triangle ABC from our last figure, yours is drawn on your paper, intersect the circle in exactly one, I'm sorry, I'm reading the wrong thing. Which one am I on? There we go. Sorry, looking at my paper and my screen are confusing me for some reason. So the sides of the triangle ABC from the last figure are all tangent to the circle with radius PK or PM or PN. And when we have that happen, we say that the circle is inscribed in the triangle. Okay, we talked about a couple class periods before circumscribed. And circumscribed means something is around it, touching all of the vertices of the triangle. Inscribed means it's completely inside of it, touching all the sides of the triangle, sides instead of vertices. The center of the in circle is the in center of the triangle. So these are related items. The in circle and its center is the in center of the triangle. And we are going to construct two more items in this section today. The first one we're going to look at is, well, both of them are going to be perpendicular lines. The first one is going to be from a point not on the original line, and the second one is going to be from a point on the original line. And these videos, of course, just like before, are also posted inside of Moodle Rooms if you want to reference them later.